This video will cover the addition of numbers in scientific notation. Now, this is going to be a little bit different than the multiplication one. The first thing that we need to pay attention to is our exponents. You need to make sure that the exponents are the same so you're able to add them. If not, you're going to have to break down that exponent apart. So let's start with the first one. There are two ways to always approach this problem. You can either increase the exponent or reduce the exponent. In this video, I'm going to show you how to reduce it. So we have 3 times 10 to the 4th power plus 4 times 10 to the 2nd power. So what I'm going to do is I'm actually going to rewrite it as 3 times 10 to the 2nd power times 10 to the 2nd power plus 4 times 10 to the 2nd power. Right now, we do have the same exponents. Now we're actually going to work on the left side to solve this. The reason that we got a 2 and a 2 is because if we follow the exponent property, 10 to the 2nd power times 10 to the 2nd power, they have the same base. You add the exponent, that will give you 4. So that's how I broke down the 4. Now, I'm going to multiply 3 times 10 to the 2nd power, and that's going to give me 300 times 10 to the 2nd power plus 4 times 10 to the 2nd power. Now that we have that, we're actually going to use a factoring rule. As you can tell, both of them have a 10 to the 2nd in common. So what I'm going to do is I'm going to remove the 10 to the 2nd power. So I'm going to rewrite this first. 300 times 10 to the 2nd power plus 4 times 10 to the 2nd power. So as I mentioned, I'm going to remove this out. Okay, because remember, if I distribute 10 to the 2nd power to 300 and to 4, we would actually get exactly the same thing. So we're pretty much just doing the distributive property backwards. So that was used to get rid of the 10 to the 2nd power. Okay, so now the only thing I need to do is add the two factors in the middle, inside the parentheses. So now we have 304. Now that is not in scientific notation, so that's what we're going to do next. We're going to rewrite this in scientific notation. So let's start by making 304 times 10 to the 2nd power. And we're going to work only with the 304, and that will give us 0.04 times 10 to the 2nd times 10 to the 2nd. That will give us at the end 3.04 times 10 to the 4th. Okay. If you want to see the proof using math that you already know, what we're going to do is just expand it. So we have 30,000 plus 400. When you add those two, you get 30,400. If you put it in scientific notation, remember your decimal point will be here. So we're going to add the decimal point, and we're going to move it 1, 2, 3, 4 times. And that will give us 3.04 times 10 to the 4th, which is exactly what we got. Now, this method is technically easier, but you should only use it to check your answer. Now, let's look at another problem. Now, in this case, we have a positive exponent and a negative exponent. So we have 3 times 10 to the negative first power plus 4 times 10 to the second power. Now, you need to make sure, once again, their exponents are the same. In this case, we have a -1 and a 2. So you need to make sure that one exponent becomes the other. You can either make the -1 a 2, or you can make a 2 a -1. So as long as you have that exponent on both sides, so you can actually factor it out. So what I'm going to do in this case is I'm actually going to make that -1 a +2. So to do that, you need to keep in mind all the numbers that will give you -1. So for example, we have 0 minus 1 will give me -1. But 0 is not the exponent that I'm looking for. You need to make sure that you're using the -1. The answer is going to be -1. And you're using the exponent 2. Now, we can also do, we can do 1 minus 2. That also gives me 1. But now that will give me a +1 and a -2. And that's not exactly what we're looking for. We're looking for a +2. So what we're going to do is we're going to use the numbers 2 and -3, because 2 minus 3 gives me -1. So now I'm going to break down that exponent like that. So I have 3 times 10 to the -3rd power times 10 to the 2nd power plus 4 times 10 to the 2nd power. And keep in mind, 10 to the -3rd power times 10 to the 2nd power, we add the exponents and we will get -1. That's where those two numbers came from. Now we're going to multiply 3 times 10 to the -3rd power. That will give you 0.003 times 10 to the 2nd power plus 4 times 10 to the 2nd power. So what I'm going to do is I'm going to remove the middle parentheses. And what I'm going to do now is I'm going to factor this. Remember, the opposite of distributing property, but what I'm going to do is I'm going to factor it out to the right side in this case. So this and this will come out, and inside I will only be left with numbers without exponents. Okay, that's why it's important that we have the same exponent with the same base. If the numbers have the same base and the same exponent, you can actually factor them. It's similar to finding the greatest common factor. In this case, we have 10 to the 2nd power. Now we just add our numbers. So we have 4.003 times 10 to the 2nd power. In this problem, we already have it in scientific notation, so we're going to keep it like that. Now let's show proof of it. If we expand and make these numbers in standard form, I'm going to get 0.3 plus we get 400. Now, when you add these two numbers, you get 400.3. Now, 400.3 is not in scientific notation. So we need to move the decimal point 1, 2. So we're going to move that decimal point twice. and that will give us 4.003 times 10 to the second power. Okay, now let's see subtraction. Now we're using very similar numbers, so we have 3 times 10 to the fourth power minus 4 times 10 to the third power. Once again, we need to split one exponent, so in this case I'm going to use a larger one just because it's a little bit easier. So what I'm going to do is rewrite this as 3 times 10 to the first power times 10 to the third power. If you add the exponents, once again, you will get 4. Just rewrite the rest. Now that we have that, I'm going to expand this. The left side is going to give me 30 times 10 to the third power minus 4 times 10 to the third power. I'm going to remove that inside parentheses. And now what I'm going to do is I'm going to factor the 10 to the third outside. Okay. Notice that I haven't done anything to the exponent other than breaking it down. But over here, you don't have to add them. You don't have to do anything else. Just factoring it out. Now that you have it like this, do a regular subtraction. So we have 30 minus 4, which gives you 26 times 10 to the third power. Now this is not in scientific notation because 26 is not equal to 1 or less or above 1 and less than 10. So what we're going to do is we're going to change the 26 in scientific notation, and that gives me 2.6 times 10 to the first power times 10 to the third power. Now let's add the exponents, and we get 2.6 times 10 to the fourth power, and you're done. Now, I'll let you come up with your own proof like we did in the previous problem.